Hello everyone. Today let's talk about how the serverful and serverless architecture works. Basically, before understanding these terms, let's try to start with why we need it. Let's suppose we are working with something, and let's suppose we are building something, and we want to manage all the things. Like we have written the code, we have built the APIs and all these backend, but now it's time to deploy that. Now we are deploying it somewhere. So how this works, like how we will do these things so that all these code we have written will get managed easily. So they have for that we have two things. One is serverful and the second thing is serverless. So serverful means, let's suppose you have written the code, you have written the APIs, and now you want this need to be hosted somewhere, right? Like, because so that the if I have built something that is accessible to me only in my PC, it is only accessible to me, but I want that whole world need to be seen my products or anything. For that we use serverful. So now in serverful, all you have all the things you have written in the code, you should need to manage them from like all the best practices to deploy the front end and all these API endpoints. All these things you need to do manually. Like this thing you can do by having a EC2 instance, or under a VPC. For the security purposes you can do that. And for maybe memory or oriented stuff, you can use containers for that. This is how the serverful architecture you can deploy. But the thing is, what are the benefits of it? What are the benefits of serverful? Firstly, in this you manage all the infra part, all these things you do manually. And the second thing is, uh, let's suppose the traffic comes to a product got too much. So how you will handle it? Like for that you can auto scale the stuff, or you can manually upgrade your systems. And the second thing is, uh, like let's suppose you have one ec2 instance, so that the app is running inside the ec2 instance will run 24 into 7. There is not like that, like if someone got the traffic, then we will we will do something. No, this will run 24 into 7. But let's suppose you get more traffic, then you can scale your systems horizontally. Like because the vertically there is limit to scale something, but in horizontally you can scale more than anything. There is sky is the limit. Then, and in this case, like the server is running 24 into 7, so there is no latency between. Like latency means the server responding to the client. Like I am client because I am requesting something from the things. So this is known as latency, like where we request something and the server is giving something to us. So in this case, because the server is already running, we don't have to think about this. And so these are few examples like ec2 and vpc, and containers, and kubernetes also comes inside the containers. So for serverful, that's the thing. In next video I will try to explain with via code. Now today I'm just explaining with theory. And the second thing to deploy things is serverless. Like serverless means you have written the code, you have you have written the APIs for front end back end, where you have done. But now it's time to deploy things. But you just deploy it somewhere, but you don't have to manage anything. Like you don't have to care about, oh, I got this much traffic, what will happen then? Oh, the traffic got minimal, this is like you have given your uh, power to someone else. Like all the power comes in the hands of cloud providers. Like, and this thing works good. Like let's suppose you are building a SaaS where you don't have that much users on their on your product. So for that you can use mostly serverless. But in serverful, where mostly the serverful use when you uses when you have multiple users and you don't want any low latency between them. So for that you use serverful. And the second thing, serverless provided, like you don't have to think about scaling. It will scale automatically. But here is one thing, like the resources, let's suppose the resources will get used only when, let's suppose I have request something, let's suppose I have searched something on somewhere and it is using serverless. So in this case, the request only comes when we will, in this time the resource will get used only when when I am requesting something. If I am not requesting anything, the server will be in the state of idle state. There will be no sort of things, like there will be no things to work on. And but due to this, the latency between the server and the client is too much. Like in this case, it goes in the state of cold start, where mostly where the servers are in the idle state. So, but for to conquer these cold start, nowadays the Cloudflare workers and the Vercel have also got into the edge functions. Supabase also works on with edge functions, where it what edge functions are, right? What edge functions do, they basically, let's suppose the data is coming from one center place, right, where the server is present, the data is coming from there. But in place of uh, data coming from the center, it comes from different entities. Like there is one data center, but the which is central part of it, but we have more than other places where our servers are present, and the data inside this data center is also present on these centers. So for this, the data comes to us. Let's suppose if the data needs to travel to more, like more distance, the more latency it will, like the more latency will increase. But due to these S functions, we can easily we get the data in minimal amount of time. And because due to this, the faster response time will also be there. So in serverless, we have lambda, like maybe it's anything, AWS or it's Google Cloud provider, anything. And this is the serverless example. And for edge functions, we have Cloudflare workers. Mostly nowadays, and I think the Cloudflare have worked really well. Like the way of scaling these things is way easier in Cloudflare. That's why I love Cloudflare. We'll try to make more content on it. So that's it for today. I hope you get something out of it. Thank you, guys.